Yo, algebros. Welcome to another day of mathematics. Isn't that exciting? Are you excited? I'm excited. You know why? Because it's Friday. And as I said that, I realized that by personalizing these messages to a specific day or time, I have just made this video not reusable for next semester. Dang it. It's okay. It's really alright. Okay, so today we are going to talk about rationalizing the denominator. So maybe yesterday you were like, whoa, Ms. Bauer, we didn't divide. Why didn't we divide? Well, because I was already throwing 3 things at you at one time. I didn't want to throw something else at you, and really, quote unquote, dividing by a radical, we need to get that radical out of the denominator. So we do that by rationalizing the denominator. So there is a little example over here if you want to take a look at it. So as you can see, they had the original problem, which was 1 over square root of 2. They multiplied it by the square root of 2 over the square root of 2. They got the square root of 2 over the square root of 4. The square root of 4 is a perfect square. It is 2, and that's your final answer. So we never want to end a problem with a radical in the denominator. So if we have a radical in the denominator, we are not finished. So when we are underneath a square root, it's fairly easy to make a perfect square underneath that radical. Okay, you just multiply it by itself. That's all you have to do. All right, so just a quick example, because when I go through these problems, I'm going to kind of skip this mental math step. So I want you to make sure you understand what's happening. So we already see that up there. So take the square root of 3 times the square root of 3. We get the square root of 9, which is just 3. We take the square root of 4 times the square root of 4. We get the square root of 16, which is 4. One more, hopefully you see a pattern. Square root of 5 times square root of 5 would be the square root of 25, which is just 5. Do you see a pattern yet? If I take the square root of 6 times the square root of 6, is it okay for me to just say that it's going to equal 6? Of course it is, which is what we're going to do throughout this whole thing. All right, so let's get started. So the denominator is square root of 3. So I'm going to multiply by the square root of 3 times the square root of 3. And I'm going to get 2 radical 3 over 3. Make this not as thick. All right, so again, we're taking out some middle steps here. All right, number 3, we have 1 over radical 7, or square root of 7. So I'm going to multiply by the square root of 7 over the square root of 7. And 1 times square root of 7 is just square root of 7, and the square root of 7 times square root of 7 is just 7. We cannot simplify. We're done. All right, next, we want to get that radical 2 out of the denominator. So we're going to multiply by the square root of 2 over the square root of 2. By multiplying by the square root of 2, that's getting that square root out of the denominator because we are creating a perfect square. Therefore, you can take the square root of that number. Does that make sense? So up top, we have 6 square root 2 over 2. But wait, there's more, because you can simplify further. 2 goes into 6 3 times, so really this is going to be 3 square root 2. Number 5. The denominator is square root of 5, so let's multiply by the square root of 5. And we get 15 radical 5 over 5. But wait, there's more. 5 goes into 15 3 times, and we get 3 radical 5. Sorry. I'm just looking ahead because I didn't look ahead before. All right, number 6. Denominator is square root of 7. We don't want the square root of 7 in our denominator, so we need to multiply by square root of 7. And we get 42 radical 7 over 7, but wait, there's more. 7 goes into 42 6 times, so our answer would be 6 radical 7. All right, let's jump down to number 12. Now, the only thing that we don't want in the denominator is that radical. So when we rationalize the denominator, we just want to take care of that square root of 16. So we don't need to multiply by the 3. So we're going to take the square root of 16 over the square root of 16. And we get square root of 16 over 3 times 4. Oh, sorry. 16. Wait a second. I made that way harder than it needed to be. What is the square root of 16? Well, it's 4. Simplification makes things easier. We still would have gotten to the same answer. Let's just go through it just to show you. Well, now this can simplify. 4 goes into 16 4 times. And you get 1 over. So we still get the same answer, but that took way longer. So always double check to make sure you can't simplify the radical ahead of time. That was my bad. So I got number 7. Psh, that's 1 over 9. Square root of 81 is 9. Okay. Okay, so let's do number 13 because that's what I was hoping 12 was going to be, but it didn't. So again, we're only worried about square root of 2. We're not worried about that 3 in the denominator because we've always been able to have just regular numbers in the denominator. No problem whatsoever. So we're going to multiply by the square root of 2. And we get 3 times 2. Which you can simplify at this point. You can either multiply it out and then simplify. You can simplify right now. I'm going to simplify right now. 2 goes into 8 4 times, so we get 4 radical 2 over 3. Let me make sure there's not an example that I missed. Let's take a look at number 19. So yes, we can go ahead and multiply by the square root of 300. That's all right. Or you can simplify the radical, whatever floats your boat. I'm going to go ahead and simplify the radical. So 300 would factor into 10 and 30, 2 and 5, 5 and 6, 2 and 3. So there's a pair of 2s and a pair of 5s. So the square root of 300, I don't know why I keep saying 30. 300 would be 2 times 5 radical 3, which would be 10 radical 3. So I'm going to rewrite this problem as 2 over 10 radical 3. All right. You can simplify at this step. You can simplify pretty much at any step in this problem. But I'm going to just go ahead and multiply and then do all my simplification in one step. 2 radical 3, 10 times 3. 2 goes into 10 5 times. Radical 3 over 15. Okay. I think I have covered anything that you might encounter. So again, you could do number 19, you could multiply it out, but you're still going to have to simplify radical 300 at some point, because if you would have multiplied square root of 300 over square root of 300, you still have 2 square root 300 over 300. And the square root of 300 obviously simplifies. So you're going to have to simplify it at some point. So whether you do it at the beginning or the middle or the end, it's really up to you. Kind of whatever you want to work with is whatever floats your boat, if you will. All right. Happy mathing. If you get to this point in the video, I would really like for you to drop like one of the animal emojis in the chat, and I might sprinkle some extra credit your way for watching the lesson and getting through it during the class period. So thank you very much. Happy mathing and have a great weekend.